Hi, welcome to Text Mining Introduction and Data Preparation. What is text mining? Text mining, also known as intelligent text analysis or text data mining or knowledge text discovery. It refers generally to the process of extracting interesting and non trivial information knowledge from unstructured text. What is the need for text mining? Let's understand this using a practical example. Suppose we have biotech industry in which 80% of biological knowledge goes only in research paper, and if a scientist manually reads 50 research paper per week, and if only 10% of those data are useful, then he manages only 5 research paper per week. The other side, on online databases like medicine adds more than 10,000 abstracts per month using text mining. Thus, obviously, the performance of gathering relevant data is increased using text mining. This shows the need for text mining. So, what are the challenges in text mining? Information is usually in unstructured textual form. We have large textual databases. Almost all publications are also in electronic form. We have very high number of possible dimensions. All possible word and phrase types are in the language. We have complex and subtle relationships between concepts in the text. AOL merges with Time Warner and Time Warner is bought by AOL. There's a lot of word ambiguity and context sensitivity. Automobile, car, vehicle and tomato all mean the same. Apple, is it the company or is the fruit? We have noisy data, for example spelling mistakes. So how does the text mining process go? First, text pre-processing, in which we have syntactic and semantic text analysis, and a feature generation, we have bag of words, and a feature selection, we have simple counting statistics. And the text or data mining, we have classification, clustering, and association. Then finally, we analyze the results. So, what are the practical applications? Potential applications are countless. For example, these are used in customer profile analysis, trend analysis, information filtering and routing, event tracks, news stories classification, web search, etc. etc. Let's understand tokenization. Here we convert a sentence into sequence of tokens, which are also called same as words. Why should we tokenize? Because we do not want to treat a sentence as sequence of characters. Tokenizing in English sentences is relatively straightforward. Use spaces as boundaries and use some heuristics to handle exceptions. So what are tokenization issues? Separate possessive endings or abbreviated forms from preceding words as shown, and separate punctuation marks and quotations from words. Dictionary creation. We create a dictionary which is used to locate occurrence of particular term in the document. This will reduce the retrieval time of an algorithm. These are stored as a linked list. Take a look at this example. In the above example, the occurrence of a terms Brutus, Caesar and Calpurnium in the documents are given. Let's understand feature generation and selection. Importance of feature generation comes in machine learning. It improves the efficiency in machine learning. And the overfitting problem, which is a problem of training the machine so much that when the actual data is placed, it behaves well to an extent and start to fail. So we improve the efficiency of training. Let's understand feature selection methods for classification. Under filter method, we first pre-process computation of score for each feature and then select, then feature according to the score. Under wrapper method, the wrapper utilize learning as a black box to score subset features. Under embedded method, feature selection is performed within the process of training the algorithm. Now let's understand parsing in detail. In parsing, we first separate words from spaces and punctuation, then we clean up, then we remove redundant words and remove words with no content. Finally, we get a cleaned up list of words which are referred to as tokens. The simple algorithm for parsing: first initialize the entire text as description, then initialize character count as the number of characters in description, then initialize line count as length of description, then set the variable num as line count into 6, and set the position and dimension of position as shown. Initialize term dimension of terms and word count as shown. First task is to search for spaces. So run a for loop in which I goes from 1 to line count. Initialize n as character count of I. Set k as 1. Inside for loop where j goes from 1 to n, that is character count of I. Set char as substring which starts at j position in description of I and goes on for length j. Check if is all white of char. If it is true, then change the position of ik to j. Increment k's value by 1. Finally, set word count of I as k. Go on till the end of both for loops. Now let's parse out the terms. Run a for loop in which I goes from 1 to line count. Let's look for the first word. If the position of first word is 0, then set terms of first word as description of I. Else if position is greater than 0, then set terms of I1 as substring which starts at first position description of I and goes on till the length of position of ij minus 1. Again in for loop where j goes from 1 to word count, check if position of ij is greater than 0. If it is so, then set terms of ij as substring which starts at the position ij minus 1 plus 1 and goes on for a length of position ij minus 1. Continue the same for both the for loops. So in this presentation we understood tokenization, dictionary creation, we got the overview of text mining, we understood feature selection, and also we studied parsing in detail. So that completes our tutorial. Pick up further tutorial of your choice and browse through it. For further help, visit us at www.dataminingtools.net.